Welcome to this video on testing for normal distributions in SPSS. So normal distributions are important, and you'll probably know this from your lectures, because certain statistical tests will assume a normal distribution. So you have to be able to test for this before you perform your analysis. So I'm going to use this data set here called diet t-tests. This should be shortly available on Vital under Know-How Academic Success. So this study involves two groups of people who were given either diet 1 or diet 2. They had their weight taken at the start and at the end of the study. So our data are arranged in different ways because we'll need to have them in different formats for the different tests that we're going to do later on. On the left here we have all of our codes for diet 1 and diet 2, and this is the total weight lost here. And this is what I'm going to use as the example for doing a normal distribution. So as with a lot of other tests that you'll do, you click Analyze, Descriptive Statistics and the Explore option. If we were to put total weight loss into the dependent list and just run a normal distribution on this, this would tell us whether or not all of our data was normally distributed, but it wouldn't break it down into the different variables. It's good practice if you can break it down to the different variables. So for this reason, I'm just going to put diet here into the factor list. I'm now going to click on plots. I'm going to make sure that histogram is ticked as well as stem and leaf, because it's good to have a graphical representation of your normality plots as well. Importantly, you must tick normality plots with tests. This is the bit that will actually run your analysis. I then just press continue and OK. Our output window should then appear. We now have our tables which tell us how many samples there are and in what group. Just an overall summary. In previous videos I've described the descriptive table, so I'm not going to go into too much detail about that now. You can see previous videos. And this is our test for normality here. So what we actually have is we have two tests. So we have the Kolmogorov-Smirnov test here, and then we have the Shapiro-Wilk test here. And we have this broken down by diet 1 and by diet 2. So the null hypothesis for a normal distribution test is that the data are normally distributed until proven otherwise, until you can prove a significant difference from that. So because none of these are significant, we have to say that they are not significantly different from that of a normal distribution. This is a slightly different way of approaching it, because when you do t-tests, for example, your null hypothesis is no difference, and a p-value that's significant will indicate that the means are significantly different. So just remember that if you're doing a normal distribution test, that when you get a p-value greater than 0.05, that you are saying, yes, the data are normal. In terms of which test to use, your lecturers might have a preference, so please do whatever your lecturers have advised. I've tended to use this KS test a bit more often, but as I say, please check. Now, the only problem with these sorts of tests, and indeed statistics in general, is that when you have only a few samples, it's much harder to prove something is significantly different. And that means that the default is almost that yes, everything is normally distributed. So you might find that you've got a small sample set that comes out as saying it's normally distributed, but in reality it's not. It's just one of the drawbacks of these tests. However, for most purposes, this should be sufficient, and we can double check this by looking at our histograms. So this is a histogram for diet 1. So a normal distribution would look something like a bell curve. Now, it's quite often that when you have real life data, especially with low sample numbers, you aren't really going to see bell curves very often. So something that just looks vaguely similar, and this isn't too far removed. Likewise, this is perhaps a little bit skewed towards the right, but it's not a million miles away. It would be nicer to have more samples. People would generally say that 60 or less would be a small number of samples. So it would be nice to have slightly more. But they don't ring alarm bells, these two graphs. And then we also have our Q plots. So these data points here should be closely aligned with this line if there really is a normal distribution. Some of them are a little bit off, but overall they're not too bad. So probably in this situation, these graphs taken together with our table, that information would say, yes, the data probably are normally distributed and you can probably perform a normal distribution test. I should point out that if you're doing something like an ANOVA, there is a slightly different way that you can test for normality, and there are different ways in SPSS that you can test, but this is just one suggested way.